Welcome everyone to my talk on hybrid heat pumps. Apologies I can't be with you, and apologies for the dark background. I was recording this quite late in the evening to get some peace and quiet. So my name is Neil Hewitt. I'm head of school of the Belfast School of Architecture and Built Environment at Ulster University and the director for the Centre for Sustainable Technologies. And I have some 30 years experience working on heat pumps and decarbonised heating systems. So briefly, I'm going to talk today about hybrid heat pumps. So the electrification of household heating has research studies have released these sort of charts where you see significant peaks in electricity demand caused by electrification of space heating compared with its current grey line across the bottom of that chart. So this work done by Imperial College. So however, since then, a lot of people have done monitored trials, and this is one example. You can see that that peak has been reduced significantly from 375 gigawatts to about 140 gigawatts over the same time period. So it's interesting to note that maybe things aren't as perhaps as serious as you would be in the electrification of space heating, but it's still quite a significant increase in electricity demand and the impact on the existing electricity infrastructure. And of course, we have a gas infrastructure. So the Manchester field trial, as one example of many examples of heat pump field trials, compared hybrid and electric, 100% electric air source heat pumps and the gas hybrid air source heat pump, where at times of colder weather, you can see that the gas boiler took over a portion of the heating load from the heat pump, and you can see a subsequent demand in electrical, this sort of drop in electrical demand, and therefore reduction in challenge to the electricity network. So hybrids look very, very interesting. And basically a hybrid heat pump is a combination of a conventional air source heat pump and a small to medium gas boiler. So the conversion to gas boiler to hydrogen boiler is already underway, and a number of suppliers already state that they have hydrogen boilers at domestic level available. So in terms of that, there seems to be no issue. What we've done at Ulster is evaluated air source heat pumps in real life situations with thermal storage and with hybrid and combinations of the above. So we have test houses, very much standard UK of the 8 million type of solid wall red brick terraced house. And we have an air source heat pump meeting the full electrically driven, meeting the full heating demand, and a thermal storage for managing peak demands, etc. It's a water-based storage. It's changing over to phase change materials at the moment. So it's storage, there was a little bit of heat loss. However, in hybrid mode, we could run in either a sort of parallel or series operation. In series operation, the heat pump would do the sort of heating up mode, and then the gas boiler would take over in periods of cold weather. In parallel operation, it's more to do with market prices. So the heat pump would operate on when the electricity was low, price was low, or the electricity network could tolerate that load, and then the gas boiler would take over. Typically, we see we can halve gas use easily, and further optimization has since taken that down to about 25–30% without challenging the network. But of course, that's network dependent and depending on the numbers of heat pumps deployed. So hybrid operations work perfectly well. Looking at the costs, as you can imagine, the pure gas one in this case is perhaps the cheapest still, and this is, you know, with our electricity price not reflecting, you know, the full cost of things, and gas not reflecting the full cost of environmental issues, etc. These things may change with CO2 taxes and whatever, but that's the way it is at the moment. And you can see that the various hybrid modes fit in above. As you'd expect, CO2 emissions, the all-electric heat pump based on Northern Ireland's current electricity mix is by far the best, but the hybrid has different forms is perfectly all right. You know, it's very similar to our storage one because our storage has high levels of losses. So we're going to reduce the losses on that. But it gives an idea of what the hybrid can do. It does significantly drop compared with a gas boiler, the CO2 emissions. Now imagine replacing that with hydrogen. So to conclude very, very quickly, the gas boiler can be replaced by hydrogen. That's straightforward. There's limitations on the gas network that need to be resolved. So how much hydrogen can we transmit? Is it the 20%? Is it higher than that? But given the fact keeping the pressure consistent with current natural gas, you'd have maybe only a third of the energy transmitted. So if we're transmitting only a third of the energy through a gas distribution network, hybrid works really, really well. We need that hydrogen built up on the network. Use the network itself as a storage vector. That's great because periods of cold weather, periods of low renewable energy generation, periods of peak demand, hybridity means that the electricity network won't be overtaxed and gas through the form of hydrogen can take over. And it allows hydrogen to be eased into the system. Space heating is low-lying costs. Space heating, that's not the right thing to say. Space heating is low value. Space heating is low value. So hydrogen has much higher value targets to get itself established with. Power generation, at times when there is low renewable energy generation, is a particularly critical one. Commercial transport processes, a particularly critical one. A report by the Rocky Mountain Institute a number of years ago identified that we can't decarbonize heavy transport. We don't know how to do it yet. Electrification in terms of weight of batteries is pointless. High temperature heat processes, over about 200, 250, we need hydrogen. So we establish these processes first, and then adjacencies with gas distribution networks could allow excess to be stored safely, one hopes, and utilised for hybrid purposes during the winter season. So that's a very quick run through of where we're at, and I apologise once again, ladies, for not being there. University commitments change rapidly these days. But it gives you a very quick overview of what hybrids can do and how they can work well with the electricity network. And again, hybrids do have probably the lowest cost base. The combination of electricity and hydrogen to provide space heating is probably the lowest cost base. So thank you very much, everybody.